Okay, so here's the idea. There's this idea of a proportional relationship, and what this says here is that it can produce an infinite number of equivalent ratios. And the idea here is this: like, if I was going to make a recipe and it said add 2 tablespoons of butter for every cup of flour, okay, then if I doubled the recipe, I would put 4 tablespoons of butter and 2 cups of flour, right? 4 to 2. And maybe if I had tripled it, I would say 6 tablespoons of butter to 3 cups of flour. And that would be a 6 to 3. So we're like 2 to 1, 4 to 2, 6 to 3. Those are all proportions that essentially give you the same ratio of one thing to the other thing. And by the way, this actually is extremely helpful in cooking. If you're going to understand proportions, one of the places where you're going to use this the most and change to equivalent proportions the most in your life probably is going to be cooking. Um, Depending on, I don't know what else kind of things you'll do, but everybody cooks, right? So anyway, a proportion is an equation that states that 2 ratios are equal. So if we have A over B equals C over D, and they just say B and D can't be 0 because you can't divide by 0, right? Okay, this is a proportion, and you read it as A is to B, as C is to D. Okay, so basic idea is that if 2 ratios are equal and the quantity of one of the ratios is unknown, you can solve it to find what's missing. Here we go. What is the solution to the proportion 7/8 equals how many 12ths? Well, notice what's happening here to m. It's being divided by 12. M is being divided by 12. So how can you undo that? You can undo that by multiplying both sides by 12. Undo what's happening to m. Okay? And then when you do that, you can multiply these two. 12 times 7 is 84, so you've got 84/8 now. And this divides out to be 10.5, and you get that as an answer, okay? So if the variable is being divided by some number because the variable's on top, then you can just multiply by that number and clear it out. Try this proportion. Okay, so if we have this proportion, A is to B as C is to D, or A over B equals C over D, then we can multiply the diagonals. We call this the cross products property, okay? And it's got a really cool feature, okay? If you multiply the diagonals, A times D, it's going to be equal to B times C. And so you can get a proportion like this and watch what happens. We know that 3/4 is equal to 9/12, right? We can multiply both top and bottom by 3 to get this new equivalent fraction. Well, look what happens when you multiply the diagonals. 3 times 12 is 36, and 4 times 9, also 36. 36 equals 36. Pretty neat, right? That works for proportions. And so here's why it works, essentially. Well, I'll go through this fast. You don't have to get too stuck on this. But if we multiplied both sides of this by the product of the denominators, right? We took B here, D here. So we multiply B times D, and we get a number. Multiply both sides by that. Then what happens here is that you can cancel out the B from both, because this is kind of like over 1, right? You know that that's over 1 and that's over 1. So we multiply top times top, and the b's cancel out. So you can say, okay, that b cancels there and that b cancels on the bottom there, and you get d times a, otherwise known as a times d. The commutative property, you can switch their order, right? Same thing on the right. You can say that d cancels there and that d cancels there. One's on the top, one's on the bottom, so they cancel, and you get b times c. And there we see what we had up in the top here, that a times d equals b times c, or the diagonals are equal. They call these the means and the extremes. The means are the ones that are closest together, like 4 and 9, and the extremes are the ones that are the numbers that are furthest apart, like 3 and 12. Okay, furthest apart meaning in number. 3 is furthest from 12 out of all of these numbers, right? That's the lowest and the highest. And these are the two that are closest to the middle. Not too important to get all stuck up on. The big important thing here is that in proportions, you can multiply the diagonals and set them equal to each other, and you can solve if you're missing a value. Look at how this works. What's the solution to the proportion 4/3 equals 8 over x? And we saw two methods. One where there was a variable on top and it was being divided by something, and we could just multiply by that thing. And then we had the one with the cross products. Well, which one do we want to use? This one's easier, the cross products, because the variable's in the denominator, so it's not being divided by that number. So in fact, you can always use this method if you want, okay? And it'll work no matter what. So here we go. We say, let's multiply the diagonals. 4 times x is 4x, and 3 times 8 is 24, so you get 4x equals 24. And then dividing both sides by the coefficient, 4, you get x equals 6. Pretty basic, right? So here's the got it problem that you're going to do. What is the solution of the proportion y over 3 equals 3 over 5? Now, it won't work out to be a whole number. That's okay. You can still find the answer fairly easily. See how you do. So what is the solution of the proportion b minus 8 over 5 equals b plus 3 over 4? This looks a little complicated because you have an expression here instead of just a single variable or a constant. But we're going to do the same thing, which is we're going to multiply the diagonals. And in this particular case, all we have to do is keep in mind that what we're doing is we're multiplying here 4 times that entire difference of b minus 8. And when we do 4 times the difference of b minus 8, we have to put that in parentheses because we need the difference of b minus 8 before we multiply by 4, right? Same thing here, the other diagonal, we're going to multiply 5 times the sum of b plus 3, okay? So that's what you see here, 5 times the sum of b plus 3. That's all got to be in parentheses. And then you just do the distributive property, 4b minus 32 equals 5b plus 15. And then we solve it like a variable on both sides kind of problem that we did in, I think it's 2-4, lesson 2-4. Yep. Subtract 4b from both sides, move this constant to the other side, we get b equals negative 47. That's the answer. That's the number that if you plug it into both, it's going to work out to be true, a true statement. Okay. So what can we do in terms of a got it problem to see if you can do this? Here's your got it problem. Okay, now this is cool and extremely useful in life. Gotta trust me on that. When you model a real world situation with a proportion, you have to write the proportion correctly so that the diagonals land in the right place, okay? You can write the proportion so that the numerators have the same units and the denominators have the same units. So miles and miles like this, hours and hours like that. That's the correct one. What you don't want to have is miles and miles, hours and hours like this, okay? It's got to be 100 miles is to 2 hours, as how many miles is to 5 hours. Okay, miles is to miles, hours is to hours, going straight across same units. Got it? We're going to apply that now. By the way, this is a good one to make a note on. Just write a couple of notes down to make sure that you got this important piece of information. So a portable media player, imagine like an iPod type of thing, has 2 gigs of storage. And that 2 gigs of storage can hold about 500 songs. If you had a similar but larger iPod media player with 80 gigabytes of storage, how many songs could that hold? So 2 gigabytes is to 500 songs, and 80 gigabytes is to X number of songs. Got it? It's the proportion that you're going to set up. Okay. Smaller media player has 2 gigabytes, can hold 500. The larger one has 80 gigabytes. You want to know the number of songs. And so we're going to write that proportion looking like this. Okay. Again, gigabytes to gigabytes and songs to songs. 2 gigabytes is to 500 songs, is 80 gigabytes is to, they put S because it represents songs. Okay. Multiplying diagonally, 2 times S is 2S, 500 times 80 is 40,000, dividing by 2, S equals 20,000. So the larger one can hold 20,000 songs. Now, fun fact, you could actually write it a different way where you had gigabytes to gigabytes, right? Uh, Gigabytes over gigabytes and songs over songs. And the thing you'd have to keep in mind is that whichever one, like, see here on this side, they match gigabytes to songs going straight up and down. This way it'd have to be gigabytes to songs going straight across. Okay, and you're always going to have either gigabytes to songs like that or gigabytes to songs like that directly, never diagonally. Okay, but you could write it like that if you wanted to. The important thing to see here is that if you wrote it like this or like this, either way, you're going to be multiplying 2 times s and 500 times 80. Okay, so these will both result in the same math problem. You've got a problem. Okay, so I think this lesson is pretty straightforward in terms of the level of difficulty. I think you'll do okay with it, but man, is it important. It's going to be important for all kinds of things in life and really, truly one of the most used as an adult, no matter what you do, kind of things. So see how you do with these problems, okay? Um, Good luck, ask questions. Certainly don't leave this lesson without asking some questions if you don't understand everything, okay? Good luck.